Hi, my name's Steven Waslander, and I'm a professor at the University of Toronto Institute for Aerospace Studies. I've been working on drones and drones-related research for over 20 years now, and started way back in my graduate degree years at Stanford University, where I built up the StarMac platform, which was one of the first quadrotor platforms that was capable of autonomous flight in outdoor conditions. I moved in 2018 to the University of Toronto, and I've been spearheading a program there that combines both drones and autonomous driving applications to motivate a bunch of interesting and deep questions in perception and planning for robotics. So here we've been working on target tracking, detection, localization and mapping, and motion planning and maneuver execution, particularly in windy conditions for drones. My most recent research on the drone side has been focused in on gimbal-based perception systems, and this adds a whole interesting level of complexity to the problem in that we now have a gimbal, which is sort of a high-quality image-stabilized camera, and we're trying to extract that information in a way that's useful for a control system that isn't directly connected, right? So that has that gimbal linkage between the camera and the vehicle platform. So this has led to a bunch of interesting questions in terms of how you can use that data and how you can connect the two and understand the kinematics of the gimbal as it's operating. I think in the drone space, it's pretty clear that autonomy is going to have a huge impact on the kind of applications that are going to be available and the things that are going to be possible in terms of aerial data collection and transport of goods, et cetera, et cetera. So I think we're going to see that autonomy itself is really going to be a differentiator in terms of how companies move forward in this space. What we're talking about here essentially is trying to get away from this paradigm of many operators supervising a single drone and move towards many drones being operated or supervised by a single operator. We want to make sure that the drones themselves or the UAVs themselves can maneuver through environments, can avoid conflict or collision, can operate safe maneuvers in the event of an accident or an incident, and recover, the payload, avoid further damage by, performing a safe landing maneuver of some sort. So I think, the more robust and the more reliable we can make our autonomous systems, onboard drones, the more they're going to be able to achieve. So why do we need autonomy for drones? I think the answer here really is it's a twofold. There's a matter of efficiency and there's a matter of safety. The drone operations today require a pilot that is dedicated to the operation of the drone. It requires an advisor that's watching the environment and the scene around the drone to look out for potential interference, and it needs potentially also a mission operator or a mission specialist that's looking at the payload or the incoming data and ensuring that the task that's actually being executed is completed. Now, as we improve or advance the levels of autonomy, the need for so many people for each drone can be diminished, and ultimately we hope to get to the case where multiple drones can be deployed in a fully autonomous manner and only require minimal supervision from an operator. So we gain effectively a massive amount of scalability and efficiency in terms of operations. We also gain on the safety side in that autonomous systems that can be provably or reliably demonstrated to be safe never fall asleep, never miss or make a mistake, right? We can increase the overall performance or safety capabilities of a system if we can turn it to a truly autonomous system and validate that it's going to operate the way we expect. And so there's a huge advantage there as the number of flights with drones starts to increase, as the longer range missions start to take place, as payloads start to expand, and the types of operations near people start to increase. Knowing that these systems are autonomous and that they can be relied on to execute the tasks they've been designed for is going to be a big win for the industry and going to allow it to grow beyond the sort of individually supervised drones that we're currently familiar with. In terms of advice for companies that are operating in this space, that are trying to build large-scale UAV operations, I think the most important thing to realize is how important and how fundamental a safety culture is to the development of reliable products. There's a lot of existing standards from the aerospace side, right? Obviously, we know how to build reliable aircraft, and scaling that down while simultaneously increasing the complexity of the onboard autonomous systems puts us in a dangerous situation where those existing regulations don't necessarily translate to what we're trying to achieve. I think we can learn some valuable lessons from self-driving cars, in fact, where we're seeing a bit of a clawback in terms of how well they can demonstrate the safety case that they need to make in order to deliver a self-driving product. And I think that same thing is going to happen with autonomous drone operations and UAV operations, especially when we start to operate over human populations, right? Moving into urban environments, performing tasks that can't be easily separated from the world around them. So when we move closer to objects, move through forests, for example. These are going to be much harder problems to solve and are going to require a much deeper understanding of the safety implications of automating different aspects of the operation of these drones. I have a couple of predictions for what's going to happen in this space over the next, I don't know, decade, 15 years. I think first off, we're going to see a large expansion in terms of the kinds of data and the sophistication with which that data is evaluated and processed to deliver real useful information to customers. So we've already seen massive expansion in terms of agriculture, in terms of aerial inspection of mining sites, long-range pipeline inspection, etc., transmission lines. So there's a ton of examples that are already happening, and the quality and the detail with which the information that's been collected is then going to be processed and curated. That's going to be an ever increasing and ever expanding market. In addition, I think we're going to start to see more and more on the delivery side. So, high value, low weight packages for point-to-point deliveries where infrastructure is available on each end to make the landing and takeoff operations safe. I think that's going to keep growing. So we've seen some good examples of this already, and more is coming. I'm very bullish on the drone space. I think we're going to see a lot more UAV operations and a lot more long-range UAV operations doing things that are traditionally managed by human piloted flight. The other thing I think that we're seeing in this domain is that there's a real emphasis on AI as the be-all, end-all, or the only tool needed to solve everything. To make these drones fully autonomous, to make self-driving cars fully autonomous, right? All of our robotics applications are seeing this huge influx of interest in how AI can solve the problems that we couldn't solve before. And I think I'm going to predict a bit of a drawback on that. So I think what's happening is that there's overexcitement in that area. And it's true that these are phenomenal pattern recognition engines and they can automate a lot of tasks that we didn't know could be automated. But what the limit is that they really are only capable up to what was available to them in the data sets that they've trained on. And so they're not an adaptable technology yet. They don't incorporate common sense. And so I think in the years to come, we're going to see a change in the way we apply AI and the way we use deep learning tools, for example, to automate systems. And we're going to come to a more principled solution that allows us to incorporate prior knowledge about constraints on the system, about how dynamics evolve over time. We're going to figure out how to use these things, incorporate them into our AI tools, and the overall system will therefore be more understandable, will fit into the safety case and the explanation of how the system's going to operate in the world, and it'll lead to a more reliable and a more adaptable system in the future.